Okay, before classification, before going to classifications, okay, once again I will tell you the virtual manufacturing. Okay, this is this figure. So I told you number of times in the previous class also. Okay, right now, okay, for any product development, if you want to do a product new product development, always they'll use the always they'll use the virtual manufacturing first. Okay, then after getting all the informations, okay, regarding the design, regarding to the design to if you want to control over the over the machines, like if you want to save any the save if you want to know about the speed of the spindle, or how much is the cutting speed. Okay, if you take CNC machines, so if you want to control over the machines, okay, to produce the products, so everything we can analyze in virtually. Okay, that is called as virtual manufacturing. First we will see everything, okay, in the computers. Okay, then we will analyze twice whether if you go to this design, okay, and if you control all these things, okay, so we will get a accurate and tolerance product. Okay, so it's very important. So first we should do, okay, regarding to the virtually, that is we want to do virtually first. We should manufacture we should manufacture the product virtually. Okay, if the customers or if the stakeholders, your employees and your company heads, okay, department heads, if everyone is okay with the virtual product, okay, virtual manufacturing process, okay, then it will go for the actual. Okay, and then the design of the product 2D drawings will go for the manufacturing department. Okay, that is real manufacturing. So this is virtual manufacturing and real manufacturing. First we will see virtually everything. Like example, if you want to weld the component, so first we will see the welding in the virtual. Okay, so how much is the distance we should keep between your electro means the means your a product, okay, where you want to weld, and you want to see the distance. Okay, there is electric rod, so you should see the distance, how much the distance we should keep, and and what is the speed. Okay, we should move the holder. So everything means electric holder, what is the distance we should keep, so how much speed we should move. So everything we can see in virtually. Okay, first we'll see virtually, then we will go to the real manufacturing of the welding, means real manufacturing of the welding process. So first virtual manufacturing, then okay, we will try to modify if anything goes wrong in virtual. Okay, if the design is not safe for the particular load, okay, then we will analyze. Then if any modify is there regarding to the design, we will modify the design. Then okay, then we will change the design to the necessary to the requirements of the customer needs. Okay, if the design is okay, then the 2D drawings, okay, we will send for manufacturing plant. Okay, then manufacturing plant will take the 2D drawings. Okay, they will buy the raw materials, how much is required, then everything. Okay, they will buy the required machines, raw materials, and then the manpower. Okay, everything they will use, and they will convert the raw materials into the products. Okay, by taking the inputs from the virtual manufacturing, what you have done, that, like control, like speed, what speed you want. Okay, what spindle speed you want, what is the cutting speed. Okay, what type of tools you should use. Okay, so everything, okay, we will analyze virtually. Okay, then we will implement those inputs, okay, in the real manufacturing the products. So this is about the vision of VM, that is virtual manufacturing. So if you go for any company now, okay, they will use this virtual manufacturing process. Okay, so this is very important. I'm telling you, this is very, very important. Like if you go for CNC machines, so manufacturing of the product example. So first they will do the simulation. Okay, they will write the program. Okay, CNC program. Okay, first they will try to execute the program in software. Okay, if in software, if it comes accurately, if the whatever you want, like 13 process or boring, internal boring, or internal threading, external threading, okay, everything they will do. They will write the program, they will execute in software. Okay, if everything is correct, then only they will write the same program in the CNC machine. Okay, they will write the same, they will copy paste in the same thing in the CNC program. okay, in the equipment, and then they will run. So first they will see in virtually, that is virtual manufacturing. They will do virtual manufacturing in a software. Then they will implement, if the programs is correct, okay, then they will implement that program in the real manufacturing product. So this is what is called as a vision of virtual manufacturing. Okay. The next we'll go for the classifications. So you have three classifications here. One is classification based on the types of product and process design. Second is classification based on the type of system integration. So last is classification based on functional usage. So if you come for first classification based on types of product and process design, you have three types in this. One is production oriented virtual manufacturing. Second is control oriented virtual manufacturing, and third is design oriented virtual manufacturing. So whatever I explained you in the previous slide, so it's in the form of first classification. See, production in the sense of the production of the products. So if you want to if you want to produce a product, okay, in CNC machine, so first we will see virtually. I told you, right, we will use the CNC, that is CNC softwares like Siemens. If you go for Siemens, so there are a lot of company, they are provided the softwares. First we will see the production of the products by virtually. Okay, so if it's okay in virtually, then we will implement the same program in the CNC machines. So that's called as production oriented virtual manufacturing. So we'll see the production of the parts. Okay, there is production of the products by virtually. Then if the program is correct, then we will implement that program in the CNC machine, so that, okay, we'll complete the task. So that is called as production oriented virtual manufacturing. Then control oriented virtual manufacturing. See, control in the sense of what type of means control you're taking on the machine, like spindle speed, or the cutting speed, or the fluid flow, whatever it may be. Okay, so whatever you are controlling, okay, with respect to the manufacturing of the product, so whatever you'll try to control, that is, so the spindle speed should be this much, the cutting speed should be this much. Okay, so all these things are controlled. Example, okay, if say I told you CFD, that is a car is moving around 300 kilometer per hour. So if the car starts to vibrate at 280 kilometer per hour, so that's called as control. So we will tell, okay, don't go beyond 280 kilometer per hour. Okay, so if a driver moves to 280 or 290 kilometer per hour, so what happens? The car will vibrate. So that's called as control. So you are controlling the products. Okay, you will try to analyze in the virtual first. Okay, we will see, you will run a car which is moving at 280 and 290 kilometer per hour, and we will see, so what's happening to the car. So what is the how the air is flowing over the body of the car. So whether if you run a car around 300 kilometers per hour, so what happens? Okay, so that the car starts vibrates or not. So all these things are, okay, control oriented virtual manufacturing. So how we should means control over the product. Okay, that is very important. That is called necessary. So these are necessary things what you should update in the product. Okay, and last is design oriented virtual manufacturing. So I told you design is nothing but, so once you do so first, okay, if you're going for a new product development, so we will make a design, and we will do the analysis. So once you do the analysis, okay, once you got to know that the design is not safe, okay, for that particular load or for the particular boundary conditions, then you should go for redesigning the model. So this is called as design oriented virtual manufacturing. It's okay, it's very, very important. In the previous slide I showed you, right, that is modify. So modifying, you will see in design oriented virtual manufacturing. So it's very important. Okay, if the design is not safe, so then you should modify the design, okay, depending upon the customer needs. So you want to see, so the customer will give the boundary conditions for you. So you should take the boundary conditions, and you should apply according to the boundary conditions, okay, to your new product which are you developed, and you should analyze. So what is going to happen? Okay, if the design is not safe, okay, automatically you should change the design. So the product design engineer will do all these things. Okay, he will, the CAE engineer, that is computer aided engineer, will do the analysis. Okay, or analyst, okay, will do the analysis. You will give the results, okay, for the boundary conditions. So this is what I am getting the result, so that the design is not safe. So once the design is not safe, automatically the product design engineer will try to modify the design. So this is depending. So this all the three, that is production oriented, control oriented, design oriented okay, is the classifications of the types of product and product design, sorry, process design. So then if you go for second type, classification is based on the type of system integrated. So one is see here you can see there are four types. One is real physical system, real information system, virtual physical system, and virtual information system. So what is the meaning of real? So real in a sense of, okay, what you will going to okay do with respect to in the manufacturing plant. That is your real prototype. So real product. So real physical system means real product, and real information system means, so what is, see, once you complete the process in the equipment, real equipment, so what happens? You'll get the feedback, right? So depending upon, you will get the information. So so how much time is required to manufacture the one product? So how much is the accuracy you are getting? So then how much is the tolerance? Okay, whether the design what you're manufacturing in the equipment, it's coming same or not. So everything, okay, everything is called as physical system. That is real physical system means what you're doing in the manufacturing plant. So once you complete the task, once you complete the product, so what are the information you're getting, okay, of the product? So that's called as real information system. So virtual physical system is nothing but what you're doing in computers. Okay, so what you are developing a design, okay, in computers, like using the CATIA, ProE, Creo, all these things are virtual physical system. So you use the softwares to design the product. Likewise, virtual information system means, so once you design the product, once you do the analysis, so what are the informations you'll get, like stress? So this is the maximum stress that the material is reaching. So this is the maximum stress. This is the strength. This is the stress. Okay, this is the deformation. So all these things are virtually. So you will design the model or design the product in the CATIA, then apply the boundary conditions, and you will see the results. So that is nothing but virtually. So physical means same thing, okay, same product, okay, design you will manufacture, okay, in the plant. Then you will apply the boundary conditions. You will test. Okay, you will take the real product and you will test, and you find, and if you find the results like stress, strain, deformation, all these things, if you do what, if you do practically, that is in the manufacturing plant, so this will become real physical system, then real information system. So once you complete the model, do the test. Once you do the test, whatever you will get the results. Okay, the stress, strain, deformation, so those are called as informations. So like this you can do in the virtually, as well as you can do really. So what have you done? Like a tensile test, a flexural test, so tensile test, torsion test, then compression test in your material science lab. So those are called as the real physical systems. Okay, once you do the test, whatever you got the results, so that's called as real information systems. So the same thing is the tensile test you can do in the software also. You can go for ANSYS, okay, ANSYS or Abacus or Naston, anywhere. Okay, you can solve the problems. So that is called as virtual. You will manufacture the product virtually in the software. You will apply the boundary conditions, you solve the problem, and you get the results. So that's called virtual physical system, virtual information system. So this is about classification based on the type of system integration. Okay, whether you are using the real life machines or the softwares. If you use softwares, that is called as virtual. If you use the real life machines to manufacture the products and to test, so that is called as real physical system. And the last is classifications based on functional usage. Okay, so this has again five different types. See, virtual prototyping, virtual machining, virtual inspection, virtual assembly, virtual operation control. So these are the five, okay, different types in functional usage. Means I told you, function means whether the product is functioning regarding to the customer needs. Okay, see, virtual prototype indicates what you manufacture virtually, like using the design software. Okay, see, virtual prototype means what you use the design software like CATIA, ProE, then Unigraphics. Okay, that you use different softwares to to design the product. Then virtual machining. So machining is nothing but, okay, you'll use the different types of machines like digital manufacturing process. That is rapid prototyping. Okay, you can use rapid prototyping, okay, or injection molding machine, or CNC machine, or extrusion process, pulverization process. So there are a lot of equipments are there. Okay, but you will see in virtually. okay, you will see virtual manufacturing, like there will be a CNC machine will be there virtually, okay, in the computer. So we will fix the raw material, okay, in the spindle, okay, then we will control the speed as well as the cutting speed, the spindle speed, okay, whatever it may be, okay, and we will try to machine the component, or we will try to produce the product. This is called as virtual machining process. Okay, this is regarding to the virtual, not the real manufacturing product. Then virtual inspection. So you can see the inspection also, whether after manufacturing the product, whether the tolerance, whatever the customer needs, okay, whether that is reaching or not. If the customer is asking, I want the diameter of 25.1 mm, so then virtually you can do the inspection whether the product is having the same diameter or not. Okay, like if you go for threading, if you go for the internal boring, if you go for internal threading, so all these things you can see, you can see, or or you can do the inspection virtually. Okay, see, virtual, design the product, then do the machining process. Okay, after that you can do the inspection also virtually. I'm telling virtually. Then virtual assembly, if you go for assembling the parts, like you done in the CAMD, right? That is called virtual assembly. So first you will create the each individual part, like screw jack, blah, 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 all are called as virtual assembly. Okay, you'll do the assembly process later. So you will do the design part. Okay, after design part you will try to assemble, right? So this is called as virtual assembly. And next is virtual operational control. So this is regarding to the, I told you, right, virtually you can control the speed of the spindle or cutting speed, okay, or the so what is the fluid, okay, or coolant, which will be used in CNC machine. So what is the coolant, at for 1 second, okay, how much is the fluent flow, what is the velocity of the fluent flow, everything, okay, you can control in the virtually. So depending upon that, okay, we can use the same all the inputs in the real product manufacturing. So this is regarding to the functional usage. Okay, this classification depending upon the functional usage. Like this, if you go for the next, okay, this is existing tools for VM. So what are the tools, okay, you have with respect to the virtual manufacturing? So if you go for the company, okay, so for design part, if you become a design engineer, okay, you should use the CAE, that is computer aided engineering. That is your analysis. Okay, that is your abacus, nastran, patron. So all these things are different softwares, okay, to do the analysis and to get the results. Okay, next, 3D 3 dimensional computer aided design, that is CAD models. Right, your SolidWorks, Creo, okay, Pro E, Unigraphics, all these things are CAD models, okay, to create the prototype, or to create the model. Then design for manufacturing and assembly. So this is nothing but, so after manufacturing a part, okay, in virtually, not really, be careful. So this is called as the tools. Okay, the tools which is used in virtual manufacturing, not real life products. Be careful. So design for manufacturing and assembly. So once you complete the design part, okay, in the Creo, by using Creo or Pro, whatever it may be, then we will try to assemble. Like your example, if you take the car, okay, so there will be different parts will be there, like engine, connecting rod. If you take engine, okay, from engine to the, so there'll be flywheels will be there, then transmission systems, outer body, then chassis, okay, then springs, okay, everything, okay. So first we will create individually parts, then we will try to assemble. So this is called as design for manufacturing and assembly. Okay, you can work in all the three departments. Either CA, you can go for CAE, either you can go for design department, or you can go for DFM, that is design for manufacturing and assembly. Next, if you go for production tools, so we have SIM, advanced modeling and simulation. Okay, so advanced modeling and simulation indicates for your castings. Okay, if you go for castings, so before going to do the practical, the castings, okay, you can simulate and you can see. Okay, you can pour the molten metal, okay, molten metal into the mold cavity, okay, and you can analyze. Okay, if I pour the molten metal, like if you take the aluminum or anything, okay, if I melt to this temperature and if I pour, okay, how much is the required time to complete the solidification process? That is from liquid to solid phase. Okay, how much time is required? Okay, in the computer, that is virtually. You pour the molten metal in the runner. Okay, it will go to the mold and it will fill the pattern. Then it will come to the runner, right? So you can see the time required, how much time is required to complete the task. Okay, that is from liquid state to solid state. So then you can see then you can analyze, okay, where does the crystal imperfections may exist. Okay, so you can analyze everything there. So this you can do in the modeling and simulation softwares. Okay, there are a lot of softwares will be there. There also for castings also, you can take the casting softwares, you can buy the casting softwares and you can analyze all these things. Then distributed into interactive simulations, you have DIS, an integrated product process development, that is IPPD, just in time. Okay, material requirements planning, manufacturing resources planning, virtual reality. So this virtual reality is very important. I told you, virtual reality means you will see the products virtually. Okay, so like your car game, that is car games. Okay, if you use the mobile phones, okay, and if you play, okay, the car gamings, so that's called as virtual reality. So you'll be seeing the product virtually, and you are feeling that, okay, and you'll be feeling that I'm riding the car. That's called as virtual reality. So these are the different softwares. Okay, it is there in production. So you can enter into the industry. Okay, in all these departments. If you can go for if you go for productions, you should know at least one or two softwares. Okay, from this production tools, and if you want to go for design tools, okay, and you should know all these things. Either one or two softwares, you should know. That is hypermesh. You want to know to mesh the product. You want to know at least design some software, SolidWorks, Creo, Pro E. Okay, so all these things are design. And right now you can go for Python also, if you know Python. Okay, for designing the product. Okay, you can enter into the industry by knowing the Python also. So all these things are the tools which will be used in virtual manufacturing. So be careful. First we will do virtually, then we will implement, okay, all these inputs into the real life products to manufacture the real life products. So this is next is quality. So quality tools are total quality management tool, then quality function, then deployment. Okay, these are the tools regarding to the quality. That is virtual manufacturing. I'm telling you virtually. Okay, if you're manufacturing virtually, and you can check the quality, also quality of the products by using this TQM tool as well as the QFD tool. Then artificial intelligence. I told you right now, AI tools are very important. That is expert systems, neural network, then fuzzy logic, object-oriented technologies, then autonomous agents. So in this AI, there is artificial intelligence. You'll get machine learning or deep learning and Python programming. Okay, to write the programs. Okay, then to do the data analysis. Okay, to collect the data. You want to know about the Apache Hadoop as well as the Apache Spark. So all these things are used for data collection. Data collection is nothing but collecting the data from past 10 years. If the company starts on 2010 example, to collect the data from past 10 years, okay, we want these tools. That is Apache Hadoop or Apache Spark. So these are the softwares. Okay, they will be used to collect the data. Okay, this is very important to analyze. So data collections, if you go for the companies, okay, they'll use the for data collection from past 5 years. If you want to collect from past 5 years, so what is the production rate? So what is the design? So what was the design previous 5 years back? So what was my design of the product? So what was the investment? Okay, I was putting for manufacturing one product. So how much raw materials was required? Okay, before 5 years back. So all these things are the data storage. Okay, to collect all this data. So you want the software that is Apache Hadoop or Apache Spark. So these are the softwares, okay, that the companies are using now to collect the data. So if you go for mechanical also, they are using these softwares. Okay, if you go for Bosch, if you go for Kennametal, or if you go for TVS, okay. So all these companies are using these softwares now, okay, to collect the data, okay, to store the data. So why they store? Because to improve the product, that is with respect to the cost, with respect to the raw materials used, to respect to the time to complete the process, or to the time to complete the product. So for the all these things, okay, we should collect the data and we should form, okay, we should form, then we should clean the data. So whichever it is not required, okay, we should clean the data. Then after that we should build a new model, or we should go for building the new prototype, that is new product development. So for this you want this AI tools, okay, that is machine learning, artificial intelligence. New, see, your machine learning will come under neural network, okay, that's that is artificial neural network. So that's ANN. Okay, so right now the mechanical companies, okay, also they are using this AI tools like machine learning. I told you Python, Java. So Java, Python, all these things. Okay, they are using the tools. Okay, next is management tools. Okay, and these management tools share quality philosophies in manufacturing strategies, then management information systems. So if you want to store the data, okay, so the MIS is used, that is management information system. That is how much raw materials are buyed, okay, on this day. So how much we are selling the products, okay, on this particular day. So all these things we should store the data, okay. So for the storing the data, we will use the MIS, that is management information system. Then for manufacturing strategy, so manufacturing strategy is nothing but to complete the product. So what type of strategy you're using to manufacture the products? So this is called as manufacturing strategy. So these are the different tools. So be careful, students. So you want to know all these things. So this is regarding to the virtual manufacturing, not real life, not real manufacturing products. So before manufacturing the products, okay, you should know all these things. Okay, so there are a lot of job opportunities there regarding to AI tools, or design tools, okay, or production tools. So if you know any 2 to 3 tools, it's enough to enter into the mechanical industry. Okay. So now we will go for next slide. So students, if you have doubts, you can ask me. Then I'll go for next slide. Any doubts in this classifications to the tools, existing tools for VM? Ashok, Fayaz, if you have any doubts, you can ask me. So there are a lot of softwares you have. Okay, you can learn. You decide. You should decide. Okay, in which department or which tool which tool I should I'm interested. Okay, to work under, and you should learn the tools, okay, regarding to your interested tool. Okay, if you want to go for production, you can learn any of this tool. If you want to go for design, you can learn any of this tool. Okay, if you want to go for AI now, that is artificial intelligence, okay, you can go through the softwares like Python, okay, then Apache Hadoop, or Apache Spark, okay. And if you want to learn regarding to the regarding to the data cleaning, okay, data cleaning analysis, okay, then you can go for the Jupyter, or Matplotlib library. So there are a lot of softwares out there, okay, right now in the AI, okay, regarding to the mechanical industries, okay. So you can learn all the softwares, okay. All this software means any two, or maximum you should learn two softwares, okay, initially, and you can enter into the mechanical industry. Then we can go for simulation tools for EM. So what are the tools, okay, uh, you have in virtual manufacturing? So what I told you in the previous slides, okay, I've written in the form of the table. Okay, you can see the level of manufacturing, simulation type, then target, then priority. So factory shop floor, okay. This factory shop floor you can create in the form of virtual environment, okay. So what type of simulation is required here? Flow simulation, then business process simulation. So this factory shop floor is used for, okay, the main purpose is the flow simulations and business process simulation. Okay, the priority is low. You can see the target, storage and logistics. The storage is nothing but that's come after completion of the products. So how much it is stored in the factory. Okay, so that's called a storage of the products. Then the production values. So how much production has been completed, okay, for 1 hour or 2 hours or 3 hours or for the particular day. So all these things, okay, we will store. We can store, okay, in this what factory shop floor and production planning and control. So for the target is mainly these three, okay, in factories shop floor. Next, manufacturing system. Here you can see the flow simulation. The flow simulation is nothing but the completion of the objective, that is products. Okay, that is flow. That's called flow simulation. So the target is nothing but layout of the system, material flow, system capacity, then control plans, planning. Okay, this priority is intermediate. So these are the 5 target, okay, in the manufacturing system. The main is material flow. That is whether we are completing the task, whether we are completing the product within the time or not. Whether whatever how much materials are used, okay, for producing of the one product. So all these things we can analyze in this manufacturing system, VM, virtual manufacturing. Then manufacturing machine tool. So in this you can see the flow simulation, then 3D kinematic simulation, 3D kinematic simulation. Okay, then you can see the target is layout of specific cell, then programming, testing. So all this comes under manufacturing machine tool. So like your this 3D kinematic simulation thing, but the movement of the, what you can say, the movement of the machines, or the movement of the what you can say, so this comes under the robotics. Okay, whenever you take whenever you want to pick and place a workpiece from one point to other point. So on this particular point, you want to see you want to go for 3D kinematic simulation. So this indicates, okay, so how much is the force is coming on the hands of the on the robots. So how much force is required to pick and place the raw material. So if you assume, okay, the raw material weight is around 1 ton. So at that particular point, okay, so how much force is, or how much force is required, okay, to complete the task. So this is called as to analyze the what will be the velocity. So at what rate we should pick and place the robots. Sorry, we should pick and place the parts or raw materials. So all these things we can see in 3D kinematic simulation. So whatever you study in the whatever you study in the 4 bar mechanism, okay, in your academics of machine, I think 4 bar mechanism. So all these 4 bar mechanisms you can do in 3D kinematic softwares. Okay, this is about to write the program. Okay, to write the program and to test whether virtual this. See, be careful, this we will do virtually, not the real life manufacturing or real life to pick and place. First we will see in virtual. Okay, we will create a robo, and there will be a workpiece will be there. So we will see whether the robo can pick and place the product or not, the raw material or not. Okay, we will see virtually first, and then if it's okay, then we will implement practically. Then components. So that is FEM, finite element analysis, multi-body simulations. So basically the components indicates, if you go for the IC engine or a fuel tank or the chassis or anything. Okay, when you do the crash analysis, so everything, so you should see the component analysis. That is called as FEM, finite element analysis. You can do finite element analysis, and you can crash, and you can see a car which is hitting to the wall, okay, at 50 km/h or 60 km/h or 80 km/h, and you can see what is the stress concentration, or what is the stress which is induced in the chassis, whether it is safe, whether the humans are safe inside the car or not. Everything, okay, everything you can analyze, okay, doing FEM, doing this FEA and multi-body simulation. So you can see what is the target, that is structural, non-linear analysis, dynamic analysis. Everything you can do, everything you can do in the component. So be careful. We will take the individual component and we will try to apply the boundary conditions, and we will see, okay, whether this is okay or not. We will do non-linear analysis. See, non-linear analysis is nothing but plastic analysis, means plasticity. So we will go beyond beyond the elastic limit, and we will apply the boundary conditions, and we will do the non-linear analysis whether the material whether the material is safe or not. Okay, whether so if you're hitting the wall at 100 kilometer per hour, whether the chassis is broken or whether the chassis is fractured or not. So everything, okay, we can do the analysis, okay, in the component. And last is manufacturing process, that is called 5. Here also we will use the FEA. That is, you can see the target, that is cutting process, that is surface properties, thermal effects, tool wear, then lifetime, then chip creation, metal forming process. Okay, so all these things, okay, we will do in FEA. So this is very complex. Means to do this type of analysis, like metal forming process, okay, like forging or extrusion process, drawing process, okay, to form the sheet metals. So this is very important, and it is very complex. Okay, it's very complex to do the analysis to get the results. So after getting the results, okay, in the virtual manufacturing, that is in the system, okay, we cannot tell, or we cannot tell 100%, okay, it will work in real life, the system real. So when you use all this in inputs, like if you go for metal forming, okay, if you want to extrude, and if you want to make a sheet metal part, okay, so in virtual, it will you can apply the temperature, okay, for the metals, and you can extrude. But practically, when you once you do, and once you apply the same inputs, okay, you can complete the task. Okay, so this was very complex, so we cannot believe the results blindly. Okay, when once you do the practically, then only you can see, okay, so that whatever the inputs, whatever you received in the virtual manufacturing, okay, it can complete the task, or it can complete the product or not. So it is called as manufacturing process. It will do in FEA, is fine element analysis. Whether you can go for ANSYS Workbench, Abacus, Nastran, Patron. So there will be a lot of softwares will be there. So we can do the analysis like surface properties, the wear. If you want to find the wear properties or thermal effects, okay, or the creep analysis, or the lifetime. So fatigue analysis, everything you can do in FEA, but we cannot say, or we cannot predict, okay, the same thing will happen in actual production or actual life. So it can deviate around 20%, 20 to 30%, it can change. So this is very complex. So only as mentioned, it is very complex. Okay, so this is about the simulation tools for VM, virtual manufacturing. So anyone has any doubt in this? So any doubt, students? It's very important. You should know all these things. For components, what you will do for manufacturing process, like a car. Okay, if you do the crash analysis, so you want to know whether the car body, okay, will get fracture, okay, at this particular speed, that 120 or 140 or 200 kilometer per hour. So all these things, okay, they will do the crash analysis. Okay, at 50 kilometer per hour, if you're running, so what will happen? 60 kilometer, 70 kilometer, 80 kilometer, and then 100. So what will be the effect, okay, on the humans, okay, okay, as well as the car body or car parts. So what will happen? So everything, okay, you can do in FEA, okay, in manufacturing process. So anyone has any doubt? If you want to find the wear properties, if you want to find the creep properties, if you want to find the fatigue properties or life of the product, everything, okay, you can solve in FEA, that is finite element analysis. So only the FEA engineer or FEA analyst, okay, will be getting more package than others. I'm telling you, if you become FEA analyst, okay, you will become you will get more package. Okay, like example, if you become design engineer, if you have some experience around 2 years, okay, you will get around if you assume, if you get around 8 lakhs per annum. But if you become that is FEI analyst, okay, you will get more than 15 lakhs. If you have same 2 years experience, you will get 15 lakhs or 20 lakhs per year. So this is what uh, so this is why the FEA is very important. That's finite element analysis. You want to know some softwares, so they'll give the design for you. So then you should do the analysis depending upon the boundary conditions. Okay, after doing the analysis, you should say, So what is going to happen, whether the material can withstand the load or not. So once the car is hit to the wall at 80 kilometers per hour, so what happens? So what is happening there? So everything you should do the analysis and you should say for the customers. I think everyone is getting right. So FEA is FEA basically the FEA is very important in the mechanical field. Okay, without FEA you cannot decide to manufacture to manufacture the product really. So once you do FEA, okay, once you got the idea, okay, that is so this is that this design is good. Okay, if I go for manufacturing this design, the material will be safe for around 10 years, 20 years. Okay, everything first you should do in FEA. You should find the results. Okay, complete the process. Then only you can go for the manufacturing of the products, the actual products. Okay, in the manufacturing plant. Then factors maximized effectiveness of VM. Here 3D visualization. So this is nothing but your 3D design. Okay, design product. So once you do the uh, once you complete the design thinking process, then product design engineer will take the inputs from the design thinking team, the technical team. Then he will draw the 2D drawings. That is the conceptual design. Then that will go for the design team. Then they'll complete the 3D modeling. So that is called as 3D visualization. 3D visualization of your product. Okay, like car or the phone or whatever it may be. Okay, then uh, then I mean identical man machine interface. So first I told you, right, like CNC machines. So if you want to work in CNC machine practically, okay, like real equipment, first we will see. So what is happening in the virtually, okay, in system. So what are the conditions? What are the interface between the man and machines? So everything we will see virtually. Then okay, we can implement the all the inputs which is given by this means computer to the real life systems. Then simulations, the interface and monitoring. So a simulation is nothing but I told you, right, simulating the or doing the analysis. Then you can go for benefits of virtual manufacturing, like quality. Okay, you can increase the quality. You can to reduce the cycle time. You can increase the productivity. The flexibility will be more. The responsiveness, okay, will be good, as well as the customer relation. So all these things are benefits if you use the virtual manufacturing. Okay, if you use virtual manufacturing, all these things will be uh, it will be good. Okay, like quality, you can increase the quality of your product when you go for real life manufacturing. You can short the time for manufacturing one product. You can increase the productivity. Okay, the flexibility, okay, will be good, as well as the customer relation. Okay, the customer relation means you want uh, the the employees as well as the customers. Okay, the relation will be good. So these are the benefits, okay, of virtual manufacturing. Then applications, and then virtual prototyping, maintenance, then virtual machine tools. Okay, materials and warehouse distribution system study and development. Virtual manufacturing for sheet metal processes. I told you, right? So all these things, okay, are the applications. That is, once you complete the process in virtual manufacturing, okay, then we'll go for virtual prototyping. That is making the product. Then maintenance. So maintenance, it will be easy. So once you complete the task in virtual manufacturing, okay, you can see the maintenance also. What does virtually? Then virtual machine tools. So what are the types of different tools you can use in virtually, so that we can implement the same tools, okay, in the practical manufacturing plant. Okay. Then material and warehouse distribution. Okay, how much material should be used? Okay, how much should be stored in the warehouse? Okay, all these things we can see in the virtual manufacturing. So according to that, we can implement in the real life and in the real life manufacturing plant. Okay, then virtual manufacturing for sheet metal processing. So I told you, okay, first we will see in virtually to manufacture the sheet metal process. Okay, then we will implement all the inputs, okay, in the real manufacturing plant, and we will produce the products, that is sheet metal. Then we'll go for CAD systems in VPD. What is VPD? Well, that is virtual product development. Okay, CAD systems. So I told you, so CAD system indicates manufacturing the manufacturing the product in the software or in the system. So that's called as CAD systems in VPD. Why you want CAD? Okay, why you want CAM? Why you want CAE? So all these things are very important. So from this slide, okay, you'll be seeing the softwares. Okay, so why you require the softwares like CAD softwares or CAM softwares or CAE softwares, okay, to come in the virtual product development. See, virtual product development indicates the product, okay, will be developed by using the softwares. Okay, that is called as virtual product development. Okay, we will see the product virtually, not really. We will not go for manufacturing directly in the real life manufacturing department or manufacturing plant. Okay, we will manufacture the product virtually. We will see, okay, if it is okay to the customers or and employees, okay, in the company, that stakeholders. If everyone agrees, then only we will take all the inputs, okay, which will be used in virtual product development. We will take all the inputs and we will convert. We'll use those inputs in the real manufacturing plant, and we'll complete the product. Okay, so so you can see the introduction. So CAD and CAM, that is computer design and computer manufacturing. Okay, generally stands for computer design and computer manufacturing respectively. Okay, designing usually starts with CAD softwares. I told you. Okay, we use the CAD softwares where actual drawing of the part to be machined in is made, which is followed by generating tool paths and CAM softwares. CAD technology, which will be equal to design technologies plus computers. Okay, the CAD process is the subset of the design process. The CAM process is a subset of manufacturing process integrated of CAD and CAM leads to automation. Like example, here the CAD, okay, your SolidWorks or Creo or ProE are used for converting the conceptual design to the actual design. So once it is converted to the actual design by using the softwares, then we will go for the CAE, that is computer engineering. We will solve the problem, and sorry, we will solve according to the customer needs, according to the boundary conditions. If it is okay, if the design is go okay, then we will go for manufacturing the product by using the CNC machines. Whether you can go for CNC lathe machines, you can go for a CNC milling machine, you can go for CNC drilling machine, you can go for, see, there are a lot of CNC machines are there depending upon your required product. Okay, if you want to go for if you want to use the CNC milling machine, then you should go for CNC milling machine. Okay, to complete the product. So that is called as we use the CAD and CAM. So if you want to use the CNC milling machine, then you want to write the programs. So to obtain the required product, you should write the programming. So once you complete the programming, you should execute in the machine. Then it will convert into a real product, right? So first you should design the softwares. Okay, if you want to convert the design into reality, okay, then you should write the programs, okay, in the CNC softwares. Okay, CNC machine softwares. Okay, you'll be having the lot of the softwares will be there. Okay, so you should write the programming in softwares, you should execute. Okay, then you should see whether the same design is obtaining in the software or not. Okay, so this is called as CAD and CAM. So CAD, so directly you can design the product, okay, by using the softwares like design softwares like CATIA, ProE, all these things. Okay, then Unigraphics. Okay, we should use this CAM, that's computer manufacturing, to complete the process. Okay, to manufacture the product virtually. Okay, we can use the CNC machines like milling machine, turning machines. Okay, so to complete the task, you should write the programming. You should execute the programming virtually, and we can see whether we can manufacture the product or not. Okay, you can see here CAD technology will be equal to design technologies plus computers. If you have the design, if you have the conceptual design, then you can use the computers. Okay, you can use the softwares to complete the task, to complete the design of the products. Then definition of CAD. So computer-aided design, it's defined as the application of computer and graphic software to aid the product design from conceptualization to the documentation. So I told you, right? First you will be having concept design, then you will complete the 3D drawings, or you will complete design, by using the softwares. You can see here the compute. You can see that you should have the computer graphics. That is which the computer should have the computer graphics plus design engineering. Okay, and you can see the geometrical modeling. So if you have the geometrical modeling, conceptual design as well as geometrical modeling, if you have the design softwares like CATIA, Pro E, and if you have the geometrical, if you have the computer graphics, you can complete the 3D model of your conceptual design. So this is nothing but the definition of CAD. So I think it's 2:30 now. Anyway, tomorrow morning I will start from NEET for CAD and CAM. Okay. Anyway, I know it's enough now. So I'll start from NEET for CAD and CAM. CAD and CAM. From this, I'll start tomorrow morning. I'll take the class. I think tomorrow within Saturday I'll finish the syllabus. Okay. Students, anyone has any doubts regarding today's class? You can ask me. So I started from the classifications. Okay, and I completed the classifications and the tools, which the existing tools in virtual manufacturing system. Then I went to the simulations. What are the simulation softwares or simulation tools we have now in virtual manufacturing? Okay, here be careful. I'm not at the Python. So right now I think mechanical industries, they're using Python from last, I think, 1 year. That's all. Okay, so that I have not updated those things here. So then after these factors maximize, then benefits, applications, then I told you what is CAD system in VPD, as well as what is the definition of the CAD. So anyone has any doubt till this, you can ask me. So tomorrow morning I will take class from 9:30 to 10:30, so that I will complete around maximum. I will try to complete tomorrow. Then Saturday another one class I will take, and I will finish syllabus. Okay, I'll go fast tomorrow, because anyway all these things I repeatedly told number of times in the first module. Okay, about the CAD, CAM, everything. So I'll go fast tomorrow. So from NEET for CAD and CAM, I'll start from tomorrow class. So anyone has any doubt? So I will share the recordings. Okay. So those who are not attended the class, they can see this recorded video and they can analyze. Okay. They can try to understand the topics.